Hello everyone, welcome to Homework Hell. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors as forces. So as per the problem, two forces F1 and F2 act at right angles to each other. The magnitude of the resultant of these two forces is 25 Newton and the magnitude of F1 is 24 Newton. And in part A, we have to determine the magnitude of F2. So the first step here is to draw a vector triangle for the two given forces and their resultant. And for the vector triangle, we'll arrange these two vectors in tip to tail or head to tail format so that we can show these two vectors and their resultant. So the vector triangle will look something like this. So vector F1, now as per the problem, the two vectors are at right angle to each other. So the other vector can be drawn as, so this can be vector F2 and they are perpendicular to each other. Now the resultant of these two vectors is the hypotenuse of this right angle triangle. And this represents the resultant vector R. Now as per the problem, the magnitude of F1 is equal to 24 newtons and the magnitude of the resultant is 25 newtons. And in part A, we have to find the magnitude of F2. So for that, we can use the Pythagorean theorem equation. So as per the Pythagorean theorem equation, so this will be the Pythagorean theorem equation for the magnitude of these three vectors. Now we can sub in the values. So 25 square is equal to 625 and 24 square is equal to 576. Now we can subtract 576 from both sides. So we get because we want to isolate magnitude of F2. And 625 minus 576 is equal to 49. And now we can apply square root to both sides. So on the right side, the square and the square root cancel each other out. And the square root of 49 is 7. So that means the magnitude of F2 is 7 and the unit is Newton. So this should be the final answer for part A. We can analyze part B. Determine the angle between vector F1 and the resultant. So we have to find this angle theta. Now since this is a right angle triangle, we can use SOHCAHTOA. So we know the magnitude of F1, so that's given to us as 24 newtons, and we know the magnitude of resultant is given to us as 25 newtons. So we can use cos ratio. So the formula for cos is adjacent over hypotenuse, and the adjacent side length is the magnitude of f1. And the hypotenuse is the magnitude of resultant. We can also use magnitude of f2, so we can use tan or sine ratio as well, but it's better to use the values that are given in the problem, so that way in case you make any mistake in doing the calculation for the length of the third side, you will still get the right answer for the angle. Now we can do the inverse of cos. So now we can evaluate this expression. So I got almost 16.3 degrees. So this should be the final answer for the first part. Next we have to find the angle between vector f1 and the equilibrant. So first we can show the equilibrant vector in the diagram. The equilibrant vector is a vector that's equal and opposite to the resultant vector. So the equilibrant vector will be shown like this. This vector is the equilibrant vector. So the angle between f1 and equilibrant vector will be this red angle. So we have to find the measure of this red angle. Now since the vector E and R, they lie along the same line, so this red angle and angle theta are supplementary angles because together they make a straight line angle of 180 degrees. So for the angle between f1 and equilibrant, we have to subtract 16.3 degrees from 180 degrees. Which is equal to 163.7 degrees. So that's the angle between f1 and equilibrant. So this should be the final answer for the second part of part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.